Mercado math, it's time to do some math. Let's Merca do it.
And if you're wondering why we're on an angle right now, it's because this should avoid the glare from my light. So I'm hoping, even though it's on an angle, that's better than not being able to see when I write on this section of the board. Now that that's out of the way, let's multiply some radicals. So multiplying radicals, you did a little of it in the last section, but then again, the last section had 4 damn parts. It was pretty big. But the idea, if you don't remember, is very simple. 2 radical 3 times 5 radical 6. You can do numbers with numbers, radicals with radicals. Integers, radicals, you can multiply. You're kind of matching them up. So you can do 2 times 5. You get your 10. Radical 3 times radical 6 is a radical 18. And then you still have to pay attention for, can you simplify? So I can break down that 18. Square root of 9, that's a perfect square, times square root of 2. Square root of 9 is 3. Radical 2, bring down this 10. And that's a 30 radical 2. That is kind of the gist, and that's the basic skill you need for this. Mistakes that happen, one of the more common mistakes is this. If I give you 4 times radical 5, that's not radical 20, that's just 4 radical 5. It's kind of like if I just gave you 4 times x, you can't actually multiply that, it's just 4x. Same idea, you'll see where this comes up in a moment. So here are 2 different examples, very similar. There's not really any tricks to these. We're going to do tricky ones after this. So these are 2 that I think a lot of you could probably figure out now without me even showing you. You probably have figured out we're going to be distributing. This is just distributing. We're multiplying radicals. Distributive property is just multiplying on steroids. Radical 2 times 4 radical 5. This is where you have to just make sure you pay attention. Numbers with numbers, radicals with radicals. That's a radical 2, so I can multiply by to the radical 5. But that 4, there's nothing to multiply with, so it stays 4. This would be 4 radical 10. That's the first one. Minus, distribute, radical 2 times radical 10. I can actually multiply those. That would be a radical 20. You always have to pay attention on if you can break something down. You've probably done radical 20 a couple times already. It's a familiar number. It's the square root of 4 times the square root of 5. I know the square root of 4, that's why I picked it. It's 2. So that's a 2 radical 5. Break down all this other crap that I couldn't do anything with. And that's your answer. You cannot go further. Do not actually subtract 4 and 2 and 10 and 5. These are not subtracting. These are not like terms. Remember from the last video of adding, subtracting, you can only add and subtract like terms. So this stops here, and you're done. That's not terrible. If you look at the amount of space it took up, not a ton. For this one, we multiply. Same thing, numbers with numbers, radicals with radicals. I can do 3 times 6. That's 18. There's nothing for that radical 11. It's still being multiplied, but I just can't multiply by anything, so it just stays radical 11 there. This is 18 radical 11. There's another minus sign. Distribute. 3 radical 11 times 2 radical 3. Numbers with numbers. 2 times 3, 6. Radical 11 times radical 3 is a radical 33. And I look and I go, can I do anything with this? Can't break down 11. Can't break down 33. And this one is now done. There's no tricks to it. It's just, that's it. It doesn't always have to be this way. It's not always going to have these extra steps. Sometimes you just multiply and you get to stop. The next 2 questions are going to be a little trickier, have a little more thought to them, all right? We're going to jump to those now. So, these are going to have the same common mistake in it, the same issue that happens, and we're going to talk a little about it, but hopefully if you understand it, and you should because you kind of did it, once again, that section, the 10-2, but once again, that section had 4 parts, so it's a good chance you might have forgot that crap. So for this, you're still going to distribute. Radical 2, I could do times radical 2. There's nothing for that 6, so it's still 6. Now this is where some of you already might realize what's happening, and some of you might need to write down the extra step. I'm going to do all the steps, but deep down, some of you are going to be able to kind of skip to this one. Radical 2 times radical 2 is radical 4. I know what the square root of 4 is. A lot of you already know the square root of 4, and you see where this is going, but I'm going to keep going as if this were just a regular problem. So once again, 6, radical 2 gave me radical 4. Radical 2 times 5. Common mistake, people love to write radical 10 here. This is not radical 10. This is a radical, this is just a regular old integer, just a plain old number. Number, radical. Remember, you could do radicals with radicals, numbers with numbers. These don't actually get multiplied, so it just stays, radical 2 times 5 is just 5 times radical 2. Nothing happens here, it just stays like that, okay? You can already see a lot of you are going to probably put radical 10. That is one of the most common mistakes we'll see as math teachers. Now this, some of you already probably know what's happening, some of you are kind of guessing. Common mistake is people write 6 radical 2 here. That's not what it is. The square root of 4 is just 2, not radical 2, 2. Square root of 4 is 2. It's a perfect square. It's one of the first ones people think of. They always forget 0 and 1. But it's 2. We bring down the 6. 6 times 2 is 12. Plus, I can't do anything with this, 5 radical 2. This is done. Now, deep down, I genuinely believe a lot of you are smart enough to figure out this step to this step without any of this crap in the middle. I think a lot of you can kind of go, oh, it's 6 times radical 2 times radical 2 is 2. You're squaring it. You're basically squaring a square root, which you remember, when you rationalize the denominator, that's how you get rid of radical. But if you need this little extra step, it doesn't take a lot of time to do it, and you're still done maybe a few extra seconds of your time. Over here, 4 radical 5 times radical 10, we distribute. Numbers with numbers, so I just have a 4. Radical 5 times radical 10, I could do radical 50. And I'm going to be able to break that down in a little bit. Minus sign, minus sign. 4 radical 5 times negative 2 radical 5. Numbers with numbers, radicals with radicals. 4 times negative 2, that's a negative 8. There's that negative 8. Radical 5 times radical 5. Deep down, I would love you just to write times 5 here. That means that you actually know what happens when you do this. If you need this little step, that is fine. Once again, I'm hoping some of you can kind of skip a step here. Once you're at that spot, we go, all right, square root of 50, I can break down 50. The perfect square that goes into 50 is 25. It is 25 times 2. The square root of 25 is a perfect square. That's why we're using it. 5, bring down that radical 2. I don't know what it is. And we also bring down this 4. 4 times 5, radical 2. You already know that's going to be 20 radical 2. I'm going to wait. Minus square root of 25. I literally just said I know the square root of 25. It's 5. So this is 8 times 5. Not 8 times radical 5, just 8 times 5. Before you learned algebra, before you learned all this crap, I could have gave you this question in middle school and asked you, hey, what's the square root of 25? And most of you would have been able to answer 5. Now, with all the new stuff you've learned, a lot of things are going on up there. All of a sudden, you put radical 5. It's the same reason once you learn negatives, you just start screwing up adding and subtracting things you already knew how to do. This is just 8 times 5. I'm actually going to write my final answer now. I have a 4 times 5. That's 20. Radical 2 minus 8 times 5 is 40. And you're done. Okay? I'm going to box my answer. This problem is done. Now, these would be considered a little trickier. And like I said, if you look, there's really nothing terribly tricky about it, but you have to fight your brain to not put a radical 10 here. You really have to, when you see 2 and you times 5, you want to put 10. You have to really remember, this is not 2, it's radical 2. You have to just be aware, radical 5 times radical 5. You just have to make sure you remember these are perfect squares. You know your perfect squares. You know at least a few of them. You know 4, 16, 25, hopefully. Maybe you don't know what the square root of 269 is, but, you know, you should know the smaller ones. All right, now we're going to FOIL next. Foiling, once again, is just distributing on steroids. So distributing is multiplying on steroids. Foiling is distributed on steroids, so it's kind of it's just like a Hulk Hogan of math here. Okay, so we're going to be foiling now. We're going to do 2 examples of foiling just to kind of show you the different things that can happen. Foiling is interesting. Sometimes you get really ugly answers. Sometimes you get these really nice answers. You just have to be comfortable with it and, not stress out about why your answer looks terrible. So we're going to foil the way we always do. If you don't remember, it's basically just distributing multiple times. I kind of picture just taking that out, and it's 4 times this binomial. It's 4 times 6 radical 2. Numbers with numbers, 4 times 6, 24. And that's just a radical 2. I can't actually do anything with that, so that stays radical 2. You did 4 times 6 radical 2. Now you got to do 4 times 3 radical 3. 4 times 3 radical 3. That's a 12 plus 12. And then that radical 3 is still there for the ride. Okay, remember you could do this 4 times that 3. That's your 12, and then the radical 3 just kind of comes along. Once you did 4 times everything, now we got to do this negative 3 radical 6 times everything there. And you're just moving down the line. So from there, you got to kind of picture that's not there. And don't forget that negative. One of the more common mistakes, signs. People love screwing up negative signs. Negative 3 radical 6 times 6 radical 2, numbers with numbers. Negative 18. And radical 6 times radical 2 is a radical 12. Negative 3 radical 6 times 3 radical 3. Negative 3 times 3 is a negative 9. Radical 6 times radical 3 is a radical 18. And right now, this looks like a big, ugly answer. And it's not going to be much prettier at the end. But this kind of looks like a mess. And sometimes your answers are going to look like this. I don't think we're going to do an example with that. I'll do, like I said, this one's going to work out kind of nice, and then the next one's going to work out really nice. But sometimes you'll get these big, ugly answers. Oh, we did purple. Let's go blue. So for this one, I'm having a hell of a time getting this marker out. And I lost purple. You always look to see, can you break anything down? Radical 2, can't do anything with radical 2. Radical 3, can't do anything with radical 3. 12, I can break down radical 12. Square root of 4 times 3. Square root of 4 is 2. Remember, square root of 4 is 2, not radical 2, just 2. 2 radical 3, and there's this negative 18 that you have to bring down. Like I said, you can keep going as far as you want here. This is going to be a negative 36 radical 3. This is literally the first thing you did in 10.2. This is the most important thing in the chapter, is just being able to break these down. 18. Can I break down 18? Yeah, I can. It's square root of 9 times square root of 2. Square root of 9, once again, you pick it because it's a perfect square. You can only break down using perfect squares. Square root of 9 is 3. Radical 2, bring down this negative 9. And I have this negative 27 radical 2. Now I'm going to bring down all this other crap I haven't used yet. I have this plus 12 radical 3. I have this 24 radical 2 that went untouched. And I'm still not done yet. Because if you notice, you have like terms again. And this is coming out, basically you did multiplication and then it became a problem from the last section. You're now adding and subtracting. Like terms, 24 radical 2 can be combined with that negative 27 radical 2. Remember, like terms, radical 2, those are the ones I can combine. 24 minus 27, same, different sign, subtract. So, and keep the more dominant sign negative. And the signs, the radical is going to stay the same. In a like term, that's radical 2, that's radical 2, this will stay radical 2. I have a 12 radical 3 minus 36 radical 3. Same thing, you subtract. For a lot of people, that's the hardest part. Keep the dominant sign. This will be a negative 24 radical 3. And this, believe it or not, is not an ugly answer. This is a pretty good looking answer. It's only 2 terms. Looks good. Once again, you will have answers that just kind of look like this. It is very common, especially when you're foiling. Get to higher levels, it's a very normal thing to have these terrible looking answers. Alright? Next one, we're going to foil one more, and then we should be able to kind of call it. The big ugly answers are actually the easiest ones to get. When you got to do all this extra work, that's what adds a little bit more to it. So the nicer the answer, the harder it actually is to get there. A lot of times you get to just stop and leave it that way. Great. Alright, so here's our next foiling problem. And hopefully some of you are looking at this going, I'm not going to foil this. But once again, if you don't know the shortcut, foiling will work out just fine. It's just going to take you a little more time than someone else who's taking the shortcut. I'm going to do 4 times everything here. 4 times 4, 16. 4 times negative 6 radical 3. 4 times negative 6, negative 24 radical 3. That one's done. 6 radical 3 times 4, 6 radical 3 times 4. I could do 4 times 6. That's a plus 24. Radical 3 is just radical 3. 6 radical 3 times negative 6 radical 3. Positive 6 times negative 6 is a negative 36. Radical 3 times radical 3 is a radical 9. And maybe there you might realize what's going to happen. You're adding and subtracting again. You're looking for like terms, and I have like terms. I see these radical 3's right here. Those are my like terms. I can combine them, and it's 24 minus 24. That's 0. That cancels out. You could put 0 radical 3, but anything times 0 is 0. These just cancel out. They're gone. You don't even really need them anymore. And then you have this. 16 minus 36 radical 9. But that's square root of 9. I know the square root of 9. The square root of 9 is just 3. So that's where you're at right now. 36 times 3. Hey, I know 36 times 3. I mean, I don't know it. I have to actually figure it out in my head. But this would be 16 minus 108. Once you're there, different signs. When you have different signs, you subtract to keep the dominant sign. So this would be negative. Where am I at? 92? No. And you're done. That big mess turned into this kind of normal number. And now we just go to the shortcut. Because technically, if you know what you're doing, you can skip all of this crap here and skip right to this if you know what's going on. That's the goal, is to go from here right to here and not need this middle section. And the way you do that is to realize these are conjugates. Conjugates. And can you get the answer a lot faster? You can. So if you remember conjugates, when you multiply conjugates, you get to use the difference of squares. So these are conjugates, a plus b, a minus b. If you notice they're conjugates, you get to use the difference of squares. The difference of squares is literally in the name. Difference of squares. Okay, if you can realize that that's what you need, the name is literally telling you the formula. Oh, they're conjugates. That means I could use the difference of squares. What's the difference of squares? It's the difference of 2 squares. So the shortcut is just kind of realizing difference. So the moment I remember difference, minus sign. Make sure you get that. 4. 4 squared is 16. Bang, 16. 6 squared, 36. Radical 3 squared, it's square root of 3 squared. You're squaring a square root. If you need to go through the process of realizing it's square root of 9 and then 3, but remember, square root of 3 times square root of 3 is just 3. This is the dream. You should be able to go from here to here without writing all of this. However, for a lot of people, people forget formulas. And the main thing to take out of this is that you can still get the right answer without remembering the formula. You can still get here 100% without knowing the shortcuts. And remember, in the end of the day, it's did you get the right answers. People try to use the shortcut and get it wrong. That's not helpful. I'd rather you do it the long way if that's the case. I would love you to be good at this and use the shortcut, but once again, there's nothing wrong with foiling. All right? I don't think we need another one. We're gonna call it here. Like I said, we had a medium-looking answer. We got a nice answer. You'll get plenty of ugly ones during the assignment. Now let's draw something. It's a grader because you all did a great job.